In this lesson, we'll continue working on functions and graphs. Previously, we've seen a few different types of transformations of functions. Transformations of functions allow us to find graphs of new functions using graphs of old functions. Previously, we've looked at horizontal and vertical shifts as well as horizontal and vertical stretches and compressions. Next, we'll look at reflections. The graph of y equals negative f of x is obtained by reflecting the graph of y equals f of x across the x-axis. In other words, all of the y values in the graph of f of x are multiplied by -1, as we see in our expression y equals negative f of x. On the other hand, the graph of y equals f of negative x is obtained by reflecting the graph of y equals f of x across the y-axis. So in this expression, all of the x values are replaced with negative x. Let's use these ideas to graph a few functions. We're going to start with the function y equals square root of x. Now you may remember how to graph this function, but let's just do a quick review in case it's been a while since you've graphed the square root function. The first thing we'll do is think about the domain of this function. We know that we can only take the square root of a positive number, so our expression inside the square root must be positive, so our domain is all x greater than or equal to 0. What about the range of this function? So what can the y values take on? Well, the square root of a number is defined to always be positive, so the range will also be all positive numbers, so all y greater than or equal to 0. Now to get a graph of this function, let's start by plotting a few points. So first of all, I know that when x is equal to 0, y is equal to 0, so we have the point 0, 0. When x is 1, square root of 1 is 1, so we get the point 1, 1. When x is 4, y is 2. When x is 9, y is 3. So we have several points on the graph of our function. We know the domain and we know the range, so we can use this information to sketch the graph of our function y equals square root of x. Notice that this function is always increasing, meaning that as x gets larger, the values of y are getting larger and larger as well. Okay, so now we have our function y equals square root of x. Ultimately, we're going to use this to graph some reflected functions, but this was a nice review of how to sketch the function y equals square root of x, which will be an important function for you to keep in mind moving forward with calculus. The next function that I'd like us to sketch is y equals the square root of x plus 2. So how do we graph this function? Well, we start with our function y equals square root of x, and we notice that y equals square root of x plus 2 is a horizontal shift to the left 2 units. In other words, this is the same thing as the square root if we want to write this in our x minus c form. So this is the square root of x minus -2. So we've moved to the left 2 units. So we pick up our graph of y equals root x and we simply move it over to the left 2 units. In other words, our initial point 0, 0 moves to the left and becomes -2, 0, which we can see when x is -2, y is 0. Our point 1, 1 moves over to the left 2 units and becomes -1, 1. Our point 4, 2 becomes 2, 2, etc. So we've picked up our graph of y equals square root of x and we've moved it to the left 2 units. So we now have a graph of the function y equals square root of x plus 2. And again, this was a horizontal shift to the left 2 units. Finally, let's use this to do some reflections. So how do I graph y equals negative root x plus 2. So my negative is on the outside, which means I'm taking my original root x plus 2 graph and I'm multiplying all the y values by -1, or I'm flipping over the x-axis. So my -2, 0, that just stays where it was. But then my 0.22, flips down to 2, negative 2. And again, we can see that both graphically from the transformation and from plugging in. So when I plug in x is 2, 2 plus 2 is 4, root 4 is 2, and then we have our negative in front. Our 0.73 again flips down to become 7, negative 3. When x is 7, 7 plus 2 is 9. Square root of 9 is 3, and our negative out front makes it a negative 3. So to get y equals negative root x plus 2, we simply start with our initial root x plus 2 and multiply all the y coordinates by negative 1, which corresponds graphically to reflecting across the x-axis. Next, let's look at y equals f of negative x. So what happens if we replace the x with a negative x? So this time we reflect across the y-axis. So what happens here? We'll start with our graph of y equals root x plus 2, and now here all of our x values are being replaced with minus x. So the minus 2, 0 in our initial graph reflects across the y-axis to become 2, 0. And again, I can see that both from the reflection, the graphical transformation, and from plugging in. When x is 2, negative 2 plus 2 is 0, so we get y is equal to 0. On our original graph, root x plus 2, the 0.22 will reflect across the y-axis, or our x values become negative x, so this point becomes negative 2, 2, which again you can see by plugging in. Negative 2 becomes 2, plus 2 is 4, and the square root of that is 2. 7, 3 becomes negative 7, 3. So when we replace x with negative x, or when we're comparing f of x to f of negative x, our graph reflects across the y-axis, or in other words, all of the x values in the initial graph are replaced with negative x. So in this lesson, we saw two final transformations of functions. We saw reflections across the x-axis and reflections across the y-axis. Keeping in mind all of these different transformations will enable us to start with our basic graphs, things like y equals x squared, y equals square root of x, and obtain new graphs via transformations.